Work it, make it, do it, make sense.
JVM Toolbox 2017, choose the right JVM language for the right task. My name is Jonatan Kazmierczak. I work as a senior consultant for Trivadis in Switzerland. In Switzerland we have such views, nice views, which we can see here. A few more information about me, apart of the fact that I like the Swiss views. I'm creator of Class Visualizer, useful tool for Java developers. Wanted to ask who knows Class Visualizer. Maybe you can raise, please, your hand. Okay, at least one person. That's great. That's great. It's really nice because actually London is from London. I have second biggest amount of downloads of Class Visualizer. So maybe the community is not in this room, but is there. That's nice. Plus, few more information. The one which I'm quite happy about is that I'm first rank in Java on HackerRank. Maybe somebody also is ranked on HackerRank here in this room. Maybe you can raise your hand. At least one person. That's great. Good. So let's come to the details already. Agenda. As you can see, I don't want to bore you with slides and such things. The main part is live coding, 3 tasks, calculation, JSON processing, text template processing. That's what we are going to work on. And I assume that I have great audience of hackers, so everybody will follow. At the bottom, in the footer, you can see the valid GitHub link, which is related to this presentation. You can download or get all the code which will be written here. Let's start with introduction. What are we going to use during this session? Of course, tools which are related to the... I expected it to be already relevant now, but the time is shifting of Java 9, so will be more relevant probably next year. But still, Java 9 is here. Scala 2.12, Groovy 2.4, and JavaScript. By JavaScript, we understand ECMAScript 2015 or ES6, running on NASCOR engine in Java 9. The tools we will combine together into one Swiss Army knife with help of Gradle. And you may ask a question, why at all should I use more than one language or more than one tool? So let's assume that your favorite tool, which represents one of the programming languages, is a knife. You can do a lot of things, very good things with the knife, and at once, one day you receive a bottle of wine. Let's assume it's Swiss wine, good red wine. And of course you can try to open it with the knife, but I don't know how well you will succeed. But you can also take the dedicated tool for that task, yes, the wine opener. But you also don't need to carry all of those 4 tools with you in that form. That would be not so convenient. For that reason, we have, in real life, solutions like that, Swiss Army knives. And the same exactly is with the programming languages. You don't need to use full-blown stack many times. You just can have, with help of Gradle, one stack, and you just use other language than your favorite one for the functionality which is difficult to achieve. And in the moment, we will see such examples. Now, team. Tools are important. Team is also important. We work in Scrum, so product owners, Scrum Master, of course, and we have a bunch of developers. Java developers, Scala, Groovy, and JavaScript developers. Yeah. I hope the audience here, you represent all of those 4 groups. I hope. Great. Now, time to start our tasks. First, calculation. We want to implement a function returning a result of multiplication of 2 numerical values. Let's think for a moment about what is behind this innocent statement. 2 numerical values. It can be anything, right? Integral values, decimal values, big, small. And of course, we don't want to lose any precision at any point of the time. Good. So it's time to start some coding. In order to start, I will start a group of my favorite IDEs. JShell is a nice IDE introduced in Java 9. I really like it. Then Scala, Groovy. As you see, every of them is working on Java 9. Usually marked somewhere here. The same about Groovy. And the same with JavaScript. In case of JavaScript shell, we have to say explicitly here that we use language ES6. Otherwise, we would be a little bit back in history. So, if we want to implement our multiplication in Java, and probably we will choose big decimal as the result, because it's safe enough. Good. As you see, we have auto-completion even here. So big decimal mul, that's my multiplication. And what can come as a parameter? The task said any two numerical values. Okay, any number. So we have number. And now we will return our result. I have to convert those two numbers to big decimals. But now, if I'm thinking about big decimal and the constructors, big decimal has many useful constructors, nearly from any numerical type, except the generic one, number. So I have to use a workaround already. First one, let's say I make to string. Okay. I will transform number to string. From string, I will make big decimal a little bit. Yes, overhead, but will work. Then multiply. And then another big decimal. And the same trick. And if we look into this code, I just want to do simple thing. I want to multiply two values. But I already wrote so long code, it doesn't fit into one line anyway, the font is big. And it's not very obvious what is going on if you see that code. And it's even more difficult to analyze it if you have more mathematical operations. So the code is like write once and then don't do anything with that. The code is not really maintainable. But the function is great. If we look into the same task in Scala, we can write it as follows. Scala has also type big decimal and also auto-completion, which doesn't work even in this moment. It's my fault actually. I forgot that it's a syntax coming from Pascal originally. Now we have it. Great, big decimal. No, I don't. Yes, I need big decimal. But why I'm putting big decimal? I may have any numerical type. The reason for that is that in Scala we have so-called implicit conversions, which means that during compilation of my invocation of the method, compiler will transform any numerical type into big decimal. So I don't need to worry what is input. It will be converted properly. And I say just A multiplied by B. Looks simple, right? You can notice here that we have also big decimal, but it's different big decimal than in Java. It's Scala math big decimal. In Groovy, I would write something. I will use the same types as in Java, because Groovy generally uses the same types. And I can say the same number A, number B. Here I can do the following. I can use big decimal dot 1, which represents value 1, obviously. Then I say multiplied by A, multiplied by B. What is going on here? Why can I do like that? What is nice about Groovy is that Groovy does a conversions of the types, which actually takes place at runtime, but it can do quite advanced conversions. I mean, a little bit more advanced than Java itself. So here, at runtime, Groovy takes this big decimal, so knows already that the result will be big decimal, then takes the number A, checks the type, makes conversions to big decimal, applies the method which is behind, and so. In fact, the result, or which classes are used and which methods, is the same as in Java, just we have one more multiplication here. But the way how we express it in code is, from my point of view, much more readable. I hope you agree with me. And then in JavaScript, unfortunately, we don't have too much of auto-completion. And maybe the reason is that we don't have clearly defined types. So maybe it's difficult to achieve that. But at least we can write a piece of code. So let's test our solution. I have few test cases. Let's start with very simple one. 4 multiplied by 0.25. 1 in Java, in Scala as well, in Groovy 1, in JavaScript 1 as well. Good, results as expected. Let's take something bigger now, some long value. In Java, result is as expected. I would like to draw your attention to the digit 1 at the end, that we have all the precision. In Scala, what happened? My 1 disappeared. In Scala, I'm losing precision already. Big decimal in Scala is 128-bit. Big decimal, or double, which means can hold up to 34 digits, and I have more, unfortunately. Groovy. In Groovy, actually, I don't need this L. Why at all I have to put L? It's rubbish, right? Doesn't make any sense. I want numbers. And Groovy knows what is the type. What I really like about Groovy is that you can write any numerical literal. By the way, the decimal literals, like 0.25, they are internally compiled as a big decimal. So you don't have doubles. By default, you can achieve them, but by default, literals are big decimals. And any literal, Groovy checks into what type does it fit. So I can make a number a little bit bigger, and Groovy determines that this is a big integer and makes a proper wrapping of the number. I like it. And in JavaScript, we also don't have this L, and here we lost even more because in JavaScript every number is equivalent to 64-bit double of Java, which means that we can get 15 digits of precision. Great. And now what happens if I'm trying to do something what doesn't make sense, something incorrect? I'm trying to multiply 1 by a. No, in Java I cannot. It's character. In Scala, 97. Yeah. In Groovy, also, I cannot do that. It's not expected type. And in JavaScript, not a number, which is also a correct result. Good. We played a little bit with the multiplication in various languages. Now let's take a look about the performance. What is the execution time in milliseconds? Java is winning, definitely. Groovy is a little bit slower, 3 times slower than Java. Scala is 5 times slower. And then JavaScript, yeah. significantly slower. But what is also maybe worth to mention about this multiplication of numbers, that in case of JavaScript and Groovy, the mathematical operations can be done at runtime, so can be even fully evaluated at runtime, which is quite useful if you want to implement calculator. Actually, yesterday, at least one speaker tried to implement calculator, and he suffered a lot during the session. in JavaScript you have it for free, and actually, which means in Java, because yeah, the Nashorn engine is in place. Now, something more advanced, JSON processing. We need a function which takes the specified JSON with list of countries and returns list containing values of the name property. Maybe it's a little complicated text, but let's look into example. We have objects representing countries, and we have the outcome. Let's try to implement this functionality. When I'm looking into Java and its standard library, I must say it's not good. I didn't find any JSON processing functionality in Java standard library. In Scala, we have something. I just have to import the right class. It's a little bit hidden, but it's there. Let's make some space. Okay, so our function, I will call it cnames, country names, to make it clear, to make it short. JSON of type string, and actually I can here explicitly define the type. So maybe you noticed in the previous example in Java, I didn't say what will be returning type. Scala inferred the type properly. Here, I may do some mistake potentially, so better if I say explicitly. That is a list of strings. And now the implementation. So JSON parse full, then my JSON, and now this is, yes, please. Yes, that's actually not okay. Yeah, we can make it. Very, very good point. Thank you for saying that. Something like that is okay, or? Okay, great. Thank you very much once again. So here we have something what is called optional. It exists also in Java. So I have to extract the content of my optional. And then if I look here, what is possible, what I can do with this optional, then I cannot do much. And the reason for that is that it returns me a type any, which is equivalent of object in Java. Actually, I lost after this adjustment, I lost the content, so maybe I will need to do it again. Yeah, actually, it's bigger than the screen. That's the reason. Yeah, of course, it will not work that way. Yeah, now it fits. Great. So I should have the history. Good. And the function itself again. JSON of type string. Good. And now JSON parse full, my JSON, and get the optional, then as instance of, and I have to say explicitly what I have here. So type any is not useful, like object in Java, we cannot do much. So I have to say that this is list, what I have as an input. Inside I have object, so it will be map. And the map has property names and the values, then it will be string as property name and any as a value, because we may have strings, numbers, arrays, and so. Then now I say, okay, we know, I forgot a letter. Good. Then now I say, okay, let's map it to something more useful. And I say, okay, C is my country. Then let's map it to the name of the value of name of the country, which I'm getting from the map. But at this particular moment, I have a type any, which is not so useful. So I have to cast it again to string. I can do again this fancy as instance of, but I can do some trick, which is simpler. I can say to string. So compiler will now know that it's a string type. Okay, accepted. Good. We have a function defined. In Groovy, we can write it as, okay, maybe before jumping to Groovy, I will actually do it in JavaScript. It's maybe more interesting. We have still the Scala implementation in mind, and we will make it in JavaScript. Here is our JSON. We don't define the type because we don't have such feature in JavaScript. Here I say JSON parse my JSON, and here I say map. Here is my country, and I map it to c.name. If you look into that, the code is pretty much similar to the code written in Scala. The difference is that I don't have this fixed type overhead. And in case of dealing with JSON, I saw quite a lot of such code. It's really pain if you have every time say what exactly is the type of this value. JSON was not, and JavaScript, because actually it's coming from JavaScript, was not meant for that to have a specific types always defined. And then we can do the same in Groovy. We expect a list of strings. We have our JSON. Actually, no, first I have to import a class. Okay, JSON slurper is in place. So my function. Maybe you also notice that in Groovy I don't write return statement. I can write it if I want to have overhead, but I don't like that. So new instance of JSON slurper. Then parse text, my JSON, and here I have a function similar to the map in JavaScript and in Scala, but it's called collect. Sorry? Thank you very much. You are following the typing. Thank you very much for that. Collect, okay, and we say C to C.name. So what are we doing here? We have some structure, which we don't say explicitly what structure is that after this parsing of JSON. And the collect method is supposed to be run on some collection which can be iterated. So at runtime actually is determined. Do we have collection? Okay, we have. Then let's iterate and do mappings on the elements. And again, this is C, and I say C.name. And what is nice, but sometimes may be confusing for somebody, this C.name can mean either property, or in our case, is I'm referencing a map. So it's a value of the key represented by name. But I personally like it. I can write very compact code, and Groovy does the heavy job for me. Tries to find, to make a proper classification of the object and use the proper methods behind the scenes to fetch the proper value. The code is compact and actually self-explaining. Yes, I want to get the name of my country C. So let's test now the implementations. By the way, in case of Java, if you are interested about how it can be done, then to read questions, please ask about that. But unfortunately, I cannot do it in the shell, and that's actually goal of this task. Here is my test case. Scala. Okay, we have a proper result. Please note that here in Scala, I'm used triple double quote. And it allows me to use freely double quotes inside. In Scala, unfortunately, in Java, unfortunately, until version 9, I still cannot do that. Have to use those backslashes. In Groovy, the same is okay, it's accepted. In Groovy, I can also use alternative syntax. Maybe let's make some space with single quote. And yeah, actually I can mix single and double quotes. They are slightly different, but generally in this case, we can assume that it's the same. And what also maybe we can mention that here is my map. So in Groovy, I don't need to, no, sorry. I'm going already too far to next example. No, this is JSON map, so it's fine. A JSON list and then JSON map. And JavaScript, of course, JSON is a native citizen of JavaScript. And we have a result as expected. Now, maybe we are interested in performance. Here we are. Anybody surprised about what we see here? I was surprised when I collected the statistics. So Java with JSON-P, I use JSON-P because it's part of Java EE7. Very good performance. Actually, Groovy surprised me a lot in this case because we have pretty much the same performance as in Java. And Groovy is fully, in this particular context, is fully dynamic. It does dynamic determination of the types. So it shows that having everything fully specific types doesn't give us, in some cases, any value. Actually, only overhead and maintenance problems. JavaScript is also not bad. It's twice slower as Groovy and Java, but I would say it's fully okay. So using JavaScript from Java is also fine. And then Scala. I would say this surprised me. From curiosity, anybody tried to do a JSON processing in Scala? Nobody. That's good. Great. Okay, so we can move to the third task, text template processing. We need a function returning defined email template filled in with provided data. Both the text as well as the data must be easy to change and or to extend. And here is our example of the email. We have few placeholders, and we will want to just get a nice version of the email with the values replaced. So we can try to code the solution. And actually, since we have here some more text to write, I have already some prepared versions, which I will copy and we will discuss them. So, yeah, here is another great feature of JShell, and actually JavaScript shell the same, that at some version of Java 9, it started to be limited to 2 lines. I don't know why, but I cannot type more than, or copy and paste more than 2 lines. So I needed to compact everything to fit into 2 lines. So I get a map of string key, which is the variable and the value. And I'm using string format. In Java, I have this function, I can use it, and here I'm using some placeholders. And when I look into that, or actually, maybe when you look into that, then you see some %s, some %n, and also here something. So it's not very obvious already from this template what we will have, what value will go there. And then we have a bunch of parameters when we extract the values. But even here with 3 parameters is not straightforward. But assuming you have more parameters, then also not so maintainable, not easy to understand, but at least correct. In case of Scala, we can do it a little bit differently. In Scala, I have the same map, string to string, but I have something like s prefix with triple double quotes. And this allows me now to embed such snippets. So actually, the dollar and curly bracket says that this is some expression, and this expression is then processed at compile time. So the whole string is broken down into the string concatenation and function and the code snippets, execution, method invocations, and so on. But at least for us as developers, it's easy to write. And easy to see actually what will come here. Yes, my hero name will come. Good. Now in Groovy, actually something similar. Yes, let stands for letter. Yes, we are sending letter. Also map string to string. Triple quotes, just we don't need any prefix. Here I can also mask a new line character. And here is my text. But please note how I can refer to the objects and their values. Groovy has quite advanced here the processing of expressions. And what is also worth to mention that the processing of the text takes place at runtime. So we have very big flexibility here. And in case of JavaScript, yes, I would like to write it, and actually it's valid. This code is fully valid. I would like to write it like that. And this is fine. Also, new line masking and new lines in the text. But unfortunately, because of current limitation of JavaScript shell, I have to pack everything into 2 lines. So I have a little bit less nice or some ugly version, but at least fits into the limitations here. So just the difference is that new lines, I'm using the explicit \n character. And that's the way how I'm referencing the values from my map or object in JavaScript, which I pass here. Okay, and now let's see how this thing works. So you may notice that actually here I have dollar and curly bracket the same as in Scala. Actually, Groovy accepts the same thing. I just didn't use it, but you can write it. And here I refer to the map and the key. Now let's try to invoke our functionalities. I will provide a map of values and keys and values, which will be replaced in our template. In case of Java, since we are in Java 9, I can use a new factory method, which I must say I like. Finally, at last, I can create my map in 1 line. Wow. I needed to wait 20 years for that. And that's really fine. I like the stuff. But now let's assume that we have a little bit bigger map than here. And then I'm taking a look, and I see maybe those two values next to each other. And I may be confused. I may think, OK, is it my key with my value? Or I'm taking already value from something else and then key from something else. So what is the key, what is the value is not really clear in that case. So still some room to improvement. I don't know if Java 9 architect is here, but if it's, then yeah, maybe we can still do something about that. But at least we have a good result. Yeah, here is our hero name. In case of Scala, we have something similar. Map. And here, I can specify what is my key, what is my value. So each time I see some two strings next to each other, I always know which one is key, which one is value. And works as well. Yes, here is our hero. In case of Groovy, I have some other possibility to express my map. I'm saying just like this. This is my map. Actually, this can stand also for the list. So then you have to look what is after. If you have only values, then it will be list. But if you have something like this, key, colon, value, then means it's map. And what also is nice here, I can skip my double quotes. Why at all? I should always put double quotes. It's overhead. And the result is here. However, if I know that you are following very precisely the code, here you see that there is empty line, but we don't see this empty line here. Yes, that's a feature which I don't fully understand. But for some reason, in those particular text, Groovy has many more advanced templating functionalities, but I'm using just the simplest one. The simplest one, for some reason, is ignoring empty lines. I don't know why. And JavaScript. In JavaScript, actually, the invocation is very similar to the one which we saw before a moment in Groovy. Just different map indicator. Actually, it's object here, but it's equivalent to map, and the same, the key or property name, and then the value. And here we are with our hero. And yeah, we have it implemented, so maybe we want to see what are the performance statistics. Okay, what happened here? Java, which everything is compiled, determined, very simple. Oh, the slowest. And Groovy, which determines everything at runtime, gives you full flexibility, turned out to be the fastest. It was also surprising for me, I must say. And you may notice that there is no JavaScript here on this diagram, and that's very unfortunate. But why, we will discover in the moment. It's related a little bit to Gradle and Java 9. So now let's combine our solutions together. We coded three different functionalities in 4 different languages. Now we probably want to do some use of them. And so we can build actually the project, obviously, with help of Gradle. And here we have a link to some issue. Yes, this issue is related to Gradle on Java 9. If we try to run it today, it fails. Is it good or bad? Yes, Java 9 is still not officially released, so yes, our Gradle colleagues still have some time to make it. Yeah, I'm sure they will be on time. What is the structure of our project? We have a build Gradle, build definition, then our sources under src mine. And then you can see we have one directory per language. And then JavaScript we put into resources because it's not processed in any special way. that's quite, I would say, simple. Now let's take a look into the build Gradle inside the file. I would say it's also simple as a build definition, right? We just apply plugins. We say, I want Java, I want Groovy, I want Scala. And repository and dependencies. In the case of Groovy, if you decide to use it, please always add this in the classifier. Unless you are working with Java pre-version 7 or early version 7, early builds, but I'm sure you are not using early builds from version 7 because Indy uses invoke dynamic. So it's really a difference in performance. And here the plus says that always we take the newest version, the subversion. And that's enough, actually, to have my build valid. Unfortunately, when I execute it on Java 9, it fails. And that's the reason why I couldn't show you performance statistic for ECMAScript 6, because I was running it on Java 8, and the support for ES6 was not yet so good in times of Java 8. Let's summarize now the information. OK, here we are. We have some now colors. We were in monochromatic mode for some time, but now we have some colors. So we can see flexibility versus safety. The red means lowest, worst, and green means excellent. Actually, in JavaScript, you can do everything, maybe sometimes more than you would like to do. And here you see the stages in the meantime. But if you compare it with safety, you can see that they are actually opposed to each other. Yes, so this is, I would say, sort of danger zone if we would like to make full application only if in JavaScript. So probably we don't have ideal language here, which is in fact the case. And we may want to mix them together and have the interoperability. And here is another matrix which can be interesting. We can see here that Java and Groovy, they are fully interoperable. Yes, the green one. Yellow means that it's quite OK, maybe with some few minor additions, but it's OK. But here is already a little bit more difficult. If you would like to invoke, for example, Scala from Java or JavaScript from Java, then you have to do a few additional steps. And actually, if you take the code from the repo here, then I'm showing actually this path, because I think it's the most relevant one. That there are unit tests written in Java which are invoking each of those functionalities. So you could see what is required to do if you want, for example, to use Scala from Java or JavaScript from Java. It's possible, but yeah, marked in orange. And then there is some summary also of the languages, which I didn't want to choose so many points, so maximum 3 points of pros and cons. We can clearly see that there is no ideal language. We will come to that slide in the moment. I just will move to the next one, and in the moment this one is coming back. I would like now to encourage you to ask questions. It's a questions time. And feel free to ask about anything, what you saw or you think is relevant. But during question times, we will have these pros and cons. So you will have time to read it. Yes, there is first question. Here you are. Maybe please wait for microphone. Will be helpful.
So I don't think it was immediately obvious, but in the case of the maps, for example, those aren't the same map types, are they? I mean, Scala's got its own collections library.
OK, so your question is if the map type used in those examples is exactly the same or they are different types. Yes, it's a very good question. Thank you. They are different. So the map used in, let me actually jump to this. Java and Groovy use exactly the same map. So, I mean, Java creates actually some immutable implementation of a map interface. But anyway, it implements map interface. Groovy, by default, with this syntax, uses linked hash map. So they are fully interoperable. Scala has own map. So if you download the code, you see that I have to do some mapping to Java map. In case of JavaScript, and Groovy maps JavaScript object to Java map, to linked hash map. So the conversion is done automatically, but it's not like that if you use the code in Java and Scala. You have different maps. So does it answer your question? Yeah, thank you. Okay. Please, next question. Oh, no questions? No, there is, of course.
Why was Scala so much slower on the JSON processing?
Could you please repeat? I didn't get exactly your...
Why was Scala so much slower?
Okay. Let's move to the relevant slide. I think it's also an interesting question. I have my impression, but please don't take it really as a final truth. My impression is that this library uses immutable types, which means that in case of map, if you add a new key and value to map, it recreates the object. And since the list of countries was quite big, the objects had, I think, tens of properties, and the list was also quite big, then I would assume that during processing, all the objects were continuously recreated. And this, of course, takes time. I noticed a big difference in time execution of Java code when you use immutable collections versus mutable ones, in case if you have to change the content. So that's my guess. That's the reason behind. But for sure, I don't know. Maybe somebody knows in the audience? Okay, yeah, so I think that may be the reason. Okay, next question. Yes, we have here, please.
How did you do the performance test?
Performance test? JUnit.
Sample size, stuff like that.
Sorry?
Sample size, how many data you processed?
Okay, we actually can take a look into the code. It's not any secret. Maybe the screen will be a little bit small, but so the tests are written as follows. Those are some definitions. Generally, I was avoiding construction of the things which are time-consuming within tests. So, for example, I have here is my collection of time. In it, actually, I preload all the data which are required. I'm creating ECMAScript, JavaScript engine, and then I have my warm-up method. And warm-up method is executing all the functionalities to make sure that all the classes are loaded, all the methods are resolved, and so on. And so it really goes through all the functionalities with the values which I'm using, and then I do the real test after that. So that gives me quite good confidence that the values which I'm collecting, the metrics are relevant. Does it answer your question, or you would like to add something to that, because it may be also valuable?
Well, usually.
Yeah, please, microphone.
I mean, the JVM does some optimizations if you run it more often. And by more often, I mean like way more often, like 10,000 times or so. Then it would be even faster.
Yes, you are right with that. The native compilation by default is 10,000 times. I could tune the number. I didn't do that because that was not not also the topic to show, or not the. It was not my intention to show how is the execution time when the code is compiled and inlined. So, of course, you can play with the test. For that reason, they are available. and the statistics will be printed at the end. So you can, if you want, for example, this warm-up function wrap into some for loop, and maybe you will get slightly different values. Anyway, I wouldn't expect the proportions to be such different. However, with JavaScript, it's a little bit different story because the bytecode is generated every time during execution. So it cannot be optimized as well as the other languages. I hope it answers the question. Yeah? OK, thank you. Next question. I'm looking. I don't see any questions. Ah, there is. Great. Here you are.
These small tests are very informative, but how is this working in heavier production environments where you have, do you have experience working in teams with multiple languages on the same codes, swapping between functionality? I mean, in the case of the template language example, or the templating, there's, wouldn't you use FreeMarker or some other templating library? So it's kind of where do you see these pros and cons actually playing out?
Yes, thank you for the question. It's very good. Maybe I will repeat it. Where those multilingual or polyglot solutions are applicable in real life, why, for example, we don't use libraries which exist? I assume you refer to Java, yes, as the main language. But OK. So, of course, I'm working mainly in Java environment. And the thing is that in most of the projects on which I'm working and which are in development phase, every day I see additional libraries added to the project, external libraries. So tens of libraries from different origins, different quality, different sources, different stage in the level of life. Some of them are already dead and no more maintained, exist in the project. And from maintenance point of view of the project is really a big pain. It may be OK for creation of the software, but not after several months, and even worse, several years of application lifetime. So the good reason to add another language is to have well-maintained functionalities. So, for example, Groovy adds a lot of libraries, but they are really well tested and they are in one package. So it's not our job to maintain those dependencies and make sure that they are all OK, or maybe we have some conflicts. Everything is already maintained by somebody else. This is the reason why we can decide to use another language. Now, from the maintainability point of view, and how it looks like in real life, I didn't meet many projects which use more than one language. I participated in some Grails projects, and then in Grails, Java and Groovy can be used, and I would say it's a normal thing. So everything what is Groovy-based, it's pretty normal that you mix those two things. In other combinations, I heard about some Scala projects, but not my personal experience, but my colleagues. They were saying that, OK, they usually met some limitations at the end. They needed some additional library. Then they were adding Scala library, and Java library. And then from Java library used in Scala is fully OK. The other way around is more difficult. So I would say typically companies want to, until now, were mainly using one language solution or one language plus Java, so Scala plus Java or Groovy plus Java. More than that, I didn't met. But I think this should actually change. And I would say two languages, it makes sense. Actually, from the spoken languages, in Switzerland, we speak 4 languages. So multilingual solutions are somehow natural for some of Swiss people. Yes, in UK, you have one language, so maybe it's less natural. Yeah, does it answer your question? OK, you're welcome. Just to mention, our time is finished, but if we have more questions, then please add it. Otherwise, we will conclude. No more questions, so thank you very much.